radiant floor heating. So we talked about radiant floor heating. What did he say is the advantages of that?
Evenly heats the room.
Low temperature difference, evenly heat the room. Also, great heat profile. What does that mean? Just
Heat profile?
yeah,
Hot, warm at the feet, cool at the nose.
yeah. So it's warm at the bottom.
Oh, okay.
It gives a little bit like even temperature eye level, so which is more comfortable. What are some of the disadvantages?
Expensive?
Expensive. What else? Neil, what are some of the disadvantages of radiant floor heating?
Maintenance?
Doesn't require a lot of maintenance.
Repair?
The fact could be very expensive.
It could leak.
Leaks is very, very significant. If it leaks, it's gonna be a big problem. What else? Which also makes you want to make sure it's functioning well before you finish the system. What else?
Furniture?
Furniture is an issue, right? If you put furniture, you are slowing down the heat. That's some of the disadvantages.
That's a
So-
problem with any of them, though.
Huh?
That's a problem.
Yeah,
with
with
any
any,
of
but
them.
for radiant floor heating is more significant.
No filtering of the air.
Does not filter there, that's true. So, we talked about this last week, and we said we need a header. So, all the loops in radiant floor heating is in series or parallel?
Ooh, it is.
There is.
That's,
Series parallel.
No, it is in parallel.
yeah.
Think of your radiant floor heating as your circuitry in the house. You're gonna have a panel with hot pipes and cold pipes, and you want those to go in parallel. So each one of them will have equal amount of heat and equal amount of pressure. So this is I'm gonna do a simple house here. And imagine this is your basement here, and this is my boiler. So I'll have a hot pipe coming from here, and we have a cold coming back. So I have one room, this is one room, another room. So we have a header coming from here. And we have another header. We have another one. So this is electricity, this will be your hot, this is your neutral. The same way goes here. And you can zone each one by valve. And you'll have a thermostat in each room that will be controlling your zone valve. So this is the basic layout of radiant floor heating system. And for your project, you might want to put the kitchen with radiant floor heating, or you might want to put your bathroom in radiant floor heating. So the heat supply to each room depends on these factors, the tube size. So if I were to try to get more radiation, so the tube size does matter because of surface area. Bigger tubes mean more heat. Tube length, again, more pipes, more length, is also more surface area. So if I have a longer pipe, it's also more surface area. I would say the area equals 2 pi r times length. This is 2 times 3.14, which is a constant, times radius, times length of pipe. Question?
So if the room that you were heating is big enough, would you wanna use multiple zones, like, say one zone here and then another zone next to it, that way?
No, for one room, we want that, you want it to be one zone. For the entire room, it's all thermostat. We'll run hot water whenever you need heat, and we'll shut off the valve.
But you're not gonna lose too much heat towards the end of the line?
No, if you distribute, that's why you need to distribute the heat evenly, and the pipe evenly throughout the house,
What?
throughout the room,
That
the floor area.
equation's volume.
Huh?
That equation's volume, because you're multiplying.
This one?
Yeah, because you're multiplying by length.
2 pi r. No, 2 pi r is,
Area.
no, it's the circumference.
When-
Pi r square is the area. So this is the circumference here.
Perimeter for.
Perimeter. Circumference, yeah.
Oh.
Is that just 2 pi times R, right?
Yeah,
Times.
yeah.
What type of pipe preferred today for?
Usually I like copper, because copper has good conductivity, so copper is still there. Some people use PEX, but I have never seen PEX coming into the room. Sometimes you use PEX all the way to the room, then in the room you put copper with the right support. Support is very important. What you put around the pipe is very important as well.
Copper probably more expensive today?
Huh?
Copper more expensive?
It's still more expensive, but again, this,
Copper on the floor?
you design that in a way that it will never be changed. Yeah. You want good conductivity, copper in the floor, they put that back and forth. There are some substitute, but copper does not rust. It's very thin, not a lot of weight, and also it's good, it has good heat conductivity. So that's something you really, steel is going to be an issue sometimes, because you can have some residue. But again, there are some options. Look at the options and see what is the warranty on that, and what is the problem. I've seen people put PEX, but PEX is very fairly new. I would not put PEX in a place where I cannot get access to, in case it leaks or sags or whatever, yeah.
Or under a floating floor with
Yeah.
no concrete?
And again, sometimes those, sometimes those pipes, okay, so sometimes the system might have a fault, and you might exceed the heat limitation for copper, for PEX, and that will ruin them. Again, it's a control issue, but you don't want to have that kind of fluid pipe inside the room, because that is going to lead to a big leak, and we said leaks are very problematic.
So you're saying that formula, there's a heat loss with when you have a larger pipe diameter?
What is the question?
The question is, right, the question is, do you lose more heat on a larger diameter?
Yes.
than that?
Yeah. Tube spacing, again, if you want to have more tubes, you might wanna lower the spacing. The more spacing, that's what we mean by the spacing between the pipe.
Do we have to count somehow size spacing between tubes or what, or just do by eye?
No, it has to be very pre-calculated before you put it in. You have, that's why we do this calculation.
6 inches, 8 inches, depending on.
Well, you have to calculate the radiation rate. How much radiation rate do you want? And there is some math involved. But if you go into a company that produce pipes for radiant flow heating, they will give it to you per square foot, pre-calculated. So the finesse comes in knowing how to fit that pipe in there, and how do you distribute those pipes throughout the room. And as Jacob said, you don't want some areas to be cold than others, so you have to have equal distribution to have uniform heat and good radiation.
That's
Fairly
what-
between the tubes doesn't matter. If you leave it empty, what's going to be there?
Up
So
there.
if
Yeah.
your pump is pumping, so how do you, question is, how do you account for that heat loss, do you pump it faster? So the faster you pump the water through the pipes, would that give off less heat, or is it?
I think he's trying to get towards like the whole distribution of
Yeah.
heat.
So the flow rate is pre-calculated. You have to really have the right amount of velocity going to the water. And again, as you said, there's a lot that goes into what is the heat coming out of it. But the spacing and the tube sizing is fixed to have velocity maximum of 3 feet per minute. If you have more heat, you can have the water go faster or slower. There's a lot to manipulate to get the heat up and down. But if it goes too fast, what happens if it goes too fast? We don't want to exceed 3 feet per minute per second, which is around I don't know what it's 1 meter per second.
Would it be
So 3 feet per
noisier, right?
second.
Would it be noisier?
Noisier, more cavitation, and again, you might not drop enough heat as much as you want. So you want the temperature to be, the velocity to be slower, between 3 feet per minute, and I think 1 foot per minute for that tubes. So again, the velocity matters, the size matter, and the space between the tubes matter, because in the inside, again, you will have, the filling also matters. If you don't have any fillings, then you'll have a lot of air in there, and air is okay, but you have to put in more heat. If you have gravel, I've seen some gravel conduct more heat. Eventually, you want the floor to be uniform temperature when you go and scan it. You want to reduce the the heat spots. Questions?
What if the flow is too fast, what happens?
First of all, you have noise. Second of all, you will not lose enough heat from the water. It's going too fast, you're not going to lose enough heat. However, in this case, because we have a lot of pipes, depending on the size and the length of the pipe, you can go a little bit faster. But at the end, you want to measure the temperature drop between the input and the output, and that should not be more or less than 20 degrees. So eventually, you want to drop 20 degrees in that radiator. Yeah.
Well, the more pipe you have, because it's radiant flow, you have a lot more pipe, would that be more of an expansion tank?
Yes.
You need a bigger or more
Yes.
than one?
Yes, that's actually a good question. The expansion tank will always have to accommodate the entire water in the system expansion. And we'll talk about that piece of calculation. So, the system has to be pressure tested over time. You don't pressure test it and wait. You pressurize it and leave it overnight to see if there's any drops in the pressure. Sometimes a small drop you cannot detect or see visually, so you monitor the leaks by performing elaborate system pressure testing over a period of time. You pressurize it, you leave it, and you see if the pressure drops. If the pressure drops, it means there's some leak in the system, and you have to go and review all the soldering and connections. Again, you have to coordinate with other people who are working on the floor. If there's electricity to be laid out, conduits, whatsoever, you have to coordinate that and see when is the best timing to radiant floor heating. So all those tips is just for you to remember. When if you get involved in that, you can go back and look at some of the tips you will need to know before installing radiant floor heating. It's not something that some novice will try to install, because again, it's expensive and it requires some expertise. So probably something you have to do with somebody for a while to understand the finesse about it and the small little tips of the trade. Again, nobody expects you to graduate from this program and be able to install something right away. And if anybody tells you that, they're wrong, and that's a lot of pressure. And that will be the wrong expectation of yourself and of them as well. So from what I've seen so far, there's a training period of at least like 3 months. That's reasonable.
Yeah, it is. I like
3 months, you go with somebody, they call it shadowing, you go with somebody, see how it's done, because we learn things here a little bit. You get some kind of idea, but you need to see somebody do it over time. By the end of 3 months, they'll be okay, they'll be confident that you know all the small little tricks in the trade and be able to do it yourself. Because I'm telling you this because there are some companies that during the interview, they will say, yeah, we'll want to put you in the truck in 2 weeks. And that is, again, it's very optimistic, depending on your background, but that's not the norm. Yes, you went to school, you know all those fundamentals, but you need some kind of training period. I mean, let's be reasonable here. Okay, calculation. fun part. So I'll explain to you the mathematics behind these calculations, and there are no way around it because at some point, as Tracy said, you know, how do we know the spacing, how do we know the pipe sizing? Somebody must have calculated it for you. Probably they have an HVAC engineer over there who will do the math. But it's good for you to know how to double check if this makes sense to you or not, if you want to. It's good to have this background. And this is our general equation. So in here we have our heat loss equation, area. What area is that? That's the area of the floor. So this is my area here. Not this area, not the pipe area, this is my area. This is my area. Temperature difference. This is the temperature difference between the room and the pipe. So what is the temperature here in the pipe? Usually 85 degrees. Temperature of the room, 75 or 65. The radiation rate is how much we are radiating per 1 square foot. So this is the radiation rate for 1 square foot, how many BTUs I'm gonna give off. So when you want to go and install the radiant floor heating, they will tell you some configuration and tell you if you install this with this spacing between the tubes and this water temperature, this is what you get for radiation rate. Every square foot will radiate this amount. So radiation rate, area of the room, temperature difference. This is the radiation rate in BTU hour per square foot of floor area. It could be a wall, but for our case is floor area. Area, panel area. What is the panel area? That's your floor. How do you calculate the floor area? Length times width, or however, or how much area you need. You might not need to have as big as this room, maybe half the room, maybe this in the middle, maybe this in the sides. So whatever you are going to run pipe through. And the temperature difference is the temperature between the room and the floor temperature. So if the water if the water temperature is around 85, what do you expect the floor to be as temperature? It's gonna be 85 eventually. It will start at 65, then it will ramp up into 85. Okay? So how do we manipulate this equation to get different variable things? So as Joe was asking, how do I increase the water temperature, water velocity? If you look in your book,
That's where the pump comes in, right?
no, but
No.
the pump will be different calculation based on the GPM per hour.
But I mean, if you're transferring the heat from your boiler
Yeah.
to your radiator, doesn't the pump, you want that right velocity, but you don't want too fast or too slow?
Yeah.
That's the
Yeah.
relationship, right?
Yeah. So if you look at page 159, second section, under radiator selection, there are all these equations. That one of them they will explain to you how you get those equations. But what I did in here, what I'm trying to do is to explain to you how do we manipulate that equation to get some kind of variable. Let's say the room is too big, the room is too small, I need to increase the temperature. So dT is the water temperature minus the room temperature. You got that? dT is Q over R radiation rate, which is the RR times the area. If I just manipulate the equation, if I want to find what water temperature I need to send to that room. So dT is also temperature of the water minus temperature of the room. It's still the same. And if I want to find what water temperature will give me that radiation rate, so I can increase or decrease the water temperature, this is what I plug in. I have the Q required for the room, radiation rate times the area plus the temperature of the room. And you can see this equation dissected here. So these are the variables. 159, temperature of the water, to find the DT. And if you want to find the, again, DT is equal also heat loss over radiation rate times area. Be mindful of the parentheses. And if I want to find the temperature of the water to increase, so let's say I have certain heat loss, I have my radiation rate, that is fixed, and I have area is fixed. I'm not gonna change the area, I cannot change the heat loss, and I have the temperature of the room, but I would like to know what water temperature is needed to reduce or increase the heat loss. Let's say I had a room that was emitting 10,000 BTU. The owner decided that this is too much, he put some insulation, now the room is too hot. So what adjustment do I do to have the system run without having a lot of cycling? He can turn on and off all the time, but that's not really doable. I mean, that's not really something you want, right? So what is the water temperature decrease required for me to achieve that heat loss? So I can go from 85 to 75 to 70 or what have you. This is, I'm gonna find the water temperature required if I want to change the fuel. And if you see, they all come from one equation over there. It's the same one, I just manipulated it. These are the equation you need. I highly doubt you will need to do that a lot, but at least you know where it come from, and it's all come from very, very simple equation.
What was on the bottom, CFM?
That's for duct.
For what?
For duct sizing. We're not there. But at least we know where that is. So this is the area. So this is something you will do if you have already made an installation, some changes done to the room, and you want to know what is the water temperature decrease or increase that you need. Let's do an example. So a room that has a heat loss of 8,000 BTUs per hour is 20 by 30. Is to be kept at 75. Water temperature is 85. What is the required radiation rate? Can you look at the book and tell me what is the equation for the radiation rate? I'm going to put the whole equation as is. So here we have Q equal radiation rate times area times delta T. That's what I'm looking for, right?
Yeah.
So I'll fill in all the numbers. What is the area?
20 by 30.
20 by 30. What is temperature difference? 75 minus, no, other way around. 85 minus 75. So can you solve for radiation rate? Yeah. If I leave this by itself here, depending on how comfortable you are with small algebra, 800 will be here, 1,000. I'm going, if this is multiplied, to get rid of this from this side, I have to divide, right? So division. And again, I have to divide by 10. So radiation rate will equal 8 over 6.
Yeah, 1.3.
1.33, and the unit for radiation rate is BTU hour per square foot. So fill in all the numbers, try to solve for radiation rate. And you know, if you have an equation and something is multiplied, you have to divide. So we divide it by 600, then we divide it again by 10, and that will give you the radiation rate. Hopefully I did it right. So if you look at it here, this is just a simple manipulation to get the radiation rate by itself. Second step, we'll find the area, dt. We solve, we get 1.33 per square foot. If you keep it on steps, it's really not that confusing. Shortcuts always try, I mean, just confusion, don't do a lot of shortcuts. Question?
The 13.33, you change it to 1.3. Why?
Keep, what do you mean?
I thought it came out to be 13.33, and it says 1.33 up there. I just must be missing the.
No, if you divide 8 by 6, that's 1.833. It's not changing anything.
1.33, okay.
Let's do another example. So a room has a heat loss of 4,000, kept at 75. Radiation rate now is 10 BTU per hour. The room is 8 by 10. What is the water temperature required?
Okay, so it has the heat loss, it has two different, it has the radiation rate.
Yeah.
So for,
Let's look at the steps. So if you look at this equation, just gonna, I don't want this one. I'll space it out a little bit. If I go over here and I have the same equation again. Okay, what do I have?
your Q is 4,000,
Okay, radiation rate,
10 BTU,
okay, area,
8.
what is the temperature difference? You don't know?
Nope.
It's 70, the water temperature, which is gonna be higher, right?
Yeah.
The water temperature is higher than the,
85, basically.
so temperature of the water minus temperature of the room. If we go another step here, go a shortcut, write everything down,
Shortcut.
I have to learn this the hard way. What is temperature water, that's what we want to find, minus temperature room 75. Okay, so now all I have to solve for is this unknown. From pre-algebra, 4,000, if I wanna get rid of this number, what I'm gonna do?
I want to get rid of what number?
10, from this side, I'm going to this side,
Divide by 10.
divide by 10. I'm gonna do it one by one now, so you will know. So that's 400, right? If I wanna get rid of the 80, what do I do?
Divide by 80.
Divide by 80.
We didn't. He's doing it right.
What is that?
5.
5, so 5 equal TW minus 75.
Now you're going to divide again.
No, add 75 to both sides.
Okay, so let's look at that. I have 5 equal TW minus 75. How do I get the TW by itself?
Add 75 both sides.
Add 75, right? So 5 plus 75, TW minus 75 plus 75. So when you do it this way, I think it's more confusing, but at least it makes more sense. 75 minus 75, that goes to 0. So TW equal 80.
Wait, we should put 75 plus 75?
So I want to get rid of this 75 in here. So some people say, well, move it gonna change the sign, but if I want to maintain this equation, I'll add 75 to both sides. So if I add 75 to my 75, that will be cancel out to 0,
Oh, okay, yeah.
and this will be 80.
And then you just go back to the equation,
No, that's it, that's what you're looking for.
oh, just the.
You're looking for the water temperature.
Oh, okay.
So if you lay it out step by step, it's less confusing. You can also take shortcuts if you want to, depending on how comfortable you are with math. This is me doing it all in one step. But again, if you take steps, simple equation, pre-algebra, it should be. Straightforward. Thank you.
Did you get same answer? Did you get same answer?
Yeah.
You did shortcut?
Yeah.
I did
You okay?
something like that.
My shortcut, because 10 times 800 is 10 times 80.
So that's the shortcut on the board, and that's for long cut?
Yeah, it's the long way.
So, let's write this down. It's on blackboard. I want you to practice, and next class we'll go do it together. Do it by yourself. See if you're comfortable with that. It is very valuable for you to know a little bit of arithmetic. It helps you out a little bit manipulate and change things. And again, they always say measure twice, cut once. A lot of installation done by eyeballing, and you end up having things that do not fit. So you need to have some kind of simple arithmetic to work it out. Does anybody did it before, like pipe fitting? You all have to measure, deduct, and know what is the size required. So we'll stop the video here.